Coming up on this episode of the IoT Inc. Business Show.
So there's two different approaches, right, to programming. One is the rules-based approach, which is historically how programming is done, where you tell the computer exactly what you want done, and then it does it. And the machine learning approach is you give the computer a goal, and you give it some data, and then you tell it to process the data with an algorithm to achieve the goal in the most optimized way that it can.
If you're like me, before I started digging into AI, it all seemed so mysterious. Not only how it worked, but also how it was put to work. But when thought of as a subset of analytics, things come into focus fast. In this episode of the IoT Show, I speak with Curtis Seare about the tools and frameworks used to incorporate AI into IoT projects.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Curtis Seare. Curtis co-hosts the Data Crunch podcast and co-founded Vault Analytics, an AI and machine learning research and reporting company. He's also the director of analytics at Shelfbucks, a retail analytics startup where he solves problems spanning IoT, AI, and retail. Curtis, welcome to the show.
Thanks for having me. Appreciate it.
So, data science and media, how did the two come together in your mind? They seem almost like left brain, right brain, or is there a thread here that you can fill us in on?
Yeah, no, I think there is actually starting to be even more of an overlap because AI and machine learning are starting to touch a lot of people, and I think as it continues to grow, it's going to touch more and more the aspects of pretty much everyone's life. And so the goal of AI and media or the podcast Data Crunch is to help explain these sort of difficult concepts to more of a general audience and help them understand what is artificial intelligence, right? It's not like the Terminator coming and going to destroy everything. It's beyond the hype. There's some very useful and interesting principles to it and applications that are happening. And I think it's important for people to be aware of it and to know how to use it and how it's going to change things.
So in a certain sense, you're communicating data, and in this case, in your daytime job or your I don't know how you would refer to the two of them, but your startup job, and then you're communicating concepts in your podcast. Is that I guess you're a communicator in both cases.
Right. Yeah. So in I would say my startup job, the retail at Shelfbucks, is definitely a lot of communication, but that's definitely more technical. So we're actually implementing algorithms and writing code and thinking how IoT and analytics can be brought to bear on certain problems in the retail space, which also includes a lot of communication. If you can't communicate what you're analyzing and thinking about, then it dies. Right. And but the podcast and the company is very much directly related to explaining these difficult concepts to people so they can understand them.
Well, we're looking forward to hearing some of those explanations. So why don't we start, if you can give us your background in AI. How did you get interested in it? How did you prepare yourself to do it? Just give us an understanding.
Yeah, good question. So I was actually a chemistry major back in college with a bent towards business and entrepreneurship. So at that time, web analytics was actually a big thing. And I went to school where Omniture, I don't know if you were familiar with Omniture, it was a big web analytics company back in the day before it was acquired by Adobe. And I did some competitions with them and just really got into the data space and web analytics in particular. And started getting some skills. Back then, there was a program called RapidMiner that could do some machine learning things and algorithms, and got into that. And just for teaching myself some of those basic concepts really launched my career into data and analytics and data science. And since then, I've worked for several companies, helping them understand how to use data and how to use analytics and how to get value from those things, up to where I am now, where we're with a startup working in retail.
Well, that's interesting because by no means is AI a new field, but it kind of has come on the scene, maybe mostly in terms of machine learning, but it's kind of came on the scene relatively recently. Are you finding that most of the folks or your peers that are actually getting their hands dirty and working with data, do they have more of a formal background or more of a, I won't say tangential, but you obviously have a science background, so you understand the data and doing, the scientific method and so forth. But which way do you sign? Is it more folks like yourself or more folks that are traditionally trained in data analytics and in AI?
Yeah, I think it's getting to be more and more where people are trained in AI in college and so forth. I think for anyone that was going through college back when I was, it's a little more of a mixed bag, just because, like you said, we didn't have it. Now, I did back when predictive analytics and machine learning were starting to be programs. In colleges, I did actually end up taking a master's degree with one of the first ones that was available. So that was very interesting. Although I did find that in this particular field, academia sometimes is a little bit behind the curve of what's actually happening in industry. And I think since then, because that was one of the first ones that was developed, it's probably gotten better and more on point. But I do think if you're going to study these topics in an academic setting, there's also something that's really important to be said about following people on blogs and following what's going on in the code and things like TensorFlow and just these things that are developing very, very rapidly that in a school classroom setting, you can't necessarily always keep up.
Right. No, that makes sense because, when you're building a curriculum, for example, chemistry, in your background or math in my background, not exactly new. What they've been teaching was pretty much the same thing they were teaching 50 years ago, 100 years ago. But when you get into these areas, it's completely new. Well, then that takes us to your podcast. Why don't you give us a little bit of information, a little bit more? I'd like to hear more about your podcast, Data Crunch, and what its purpose is and what your approach to it is and who you target with it.
Yeah, that's a good question. So the approach there is really exploring the applications of AI and machine learning. So when we started it, I'm a huge fan of podcasts, and I really love being able to listen to them on my commute and doing other things. And I couldn't really find one. There are many good podcasts that deal with machine learning and artificial intelligence, but most of them, with the exception of a few, are dedicated towards the more technical aspects.
Yes, right.
And I couldn't find anything that could give me sort of a broad overview of what applications were actually being produced. And I've always been interested in entrepreneurship and just learning how these technologies are being applied to unique and niche situations. And we just couldn't find that. And so we decided to start a podcast aimed at exactly that. So what are the actual things that people are building, and how are they building them, and how are they impacting people? From people catching pirates on the high seas to people interpreting chicken language. I mean, there's so many things that are so interesting that you don't need the technical background to understand a lot of it, but it's important to see just the applications that are coming out of it.
All right. Well, I have to ask about the chicken language. Can you fill in the blanks on chicken
Sure.
language? I got to hear about this.
Yeah, no. So they actually developed this. There's a paper on it. You can read it where they. It's a big problem because chickens, are a big food source, and keeping chickens healthy is a big problem for farmers. And so knowing when a chicken is overheated or stressed or sick, or any of those kinds of things are kind of hard to parse out. So they ended up taking a bunch of chickens and some USB microphones and sort of putting them through mild, stressful situations. I don't think they hurt any chickens, hopefully.
No chickens were hurt in this.
No chickens were hurt.
Experiment.
That's right. Okay. But, like raising the temperature a little bit and stuff like that. And they kind of recorded what they sounded like.
Right.
And so now they have a machine learning model that can detect when chickens are kind of stressed and need some more attention, or maybe a cooling system or something is off in one of the barns and they need to go fix that. So just those kinds of things that listens to the chickens as they squawk and interprets what they're saying.
Now, for our audience listening right now, who are you targeting then for Data Crunch? It sounds pretty broad, but do you have a particular target audience?
Yeah, I think it is broad. I think we're targeting a subject that I think a lot of people can benefit from. If you're an AI researcher or, writing the code in industry, I think you're very focused on one specific niche, but perhaps learning what's going on in other industries could help creativity or just learning what the things are doing. But also a business audience in terms of just knowing what are the limits of AI and what can it actually do versus what it can't do. I think oftentimes going through examples in various industries can help you get a sense for that. So that's really what we're hoping to do.
Yeah, no, I think there's a lot of value there because it's just it's clickbait headlines that kind of get underneath my skin. And even before we started speaking today, I came up with one. I read one, and they're all to the effect of, the Singularity Event or how they're going to, take over jobs. But I have to tell you, Curtis, that the more I learn about AI, the less I'm worried about these things because it's so hard to do what they call narrow AI, to be able to just project this. And okay, a decade, 2 decades, fine. But to be able to project this into general AI and being able to have some sort of, real cognitive abilities just it just seems really far out there. I don't know what your thinking is on that. Do you side on the Elon Musk, Bill Gates side of we need to really, really be concerned about this? This is an existential threat. Or are you on the side of we got bigger chickens to worry about than that?
Yeah, really big chickens. No, I agree with you. I think it's totally overhyped in the media because that gets clicks. I think we should definitely need to be concerned about AI, but not for the reasons of it being cognitive and being what's termed a strong AI and being, able to think for itself and do all these kinds of things. So that to me that's a level beyond anything that we have currently and anything that we've even seen. And so being able to predict that also, it's a research problem, right? Yeah, and so being able to predict when a research problem will be able to come up with the technology that can achieve something like that is basically impossible. So
exactly.
Yeah, so I wouldn't be worried about that. I think a lot of the people saying it's decades and decades away, and a lot of the really smart researchers say it's not even possible. So, we just don't know with that.
But you said you kind of implied there was an area though to be concerned about.
There definitely is. I think in a few areas. So one area, for example, is just the bias that comes with this. So, for example, there are AI systems being used today that will help a judge give a sentencing to somebody. And if you feed all the data into a computer and it comes out and tells you, look, this person has a 90% chance of going back into jail if you let them out or something like that, you're kind of, you're inclined to believe what the machine is telling you oftentimes.
Right.
But what they don't understand sometimes is that, the data that's feeding that algorithm has its own biases and oftentimes has the biases that society has had for a long time, be it racial or whatever it may be. And so I think there's some very subtle things that we should be concerned about with AI that we need to think about.
Yeah, bias. I think you're right. I mean, that is a big issue, and especially when you apply it to minority report kind of applications, right? Where you're predicting something's going to happen or predicting, what's going to happen after something has happened. That's true. That is interesting to me. And people do tend to believe machines because I think they equate them kind of like big old calculators, like you're not going to argue when you multiply, 2,655 by 124,621. Now, there's some people that can do this in their head, but not many. But when you get that back from a calculator, you're not exactly going to argue with it. And I think people, because of naivety, they don't understand how these models are created, but it comes down to the data. And it's very different, right? It's not, you hear some people that are arguing on the side of the deep intelligence or general intelligence, where they say, already here, we're being outcomputed, and they bring up the example of a calculator, but that is so specific, and then it is completely, that's a direct, that's a direct mathematical representation. Whereas when we talk about AI and specifically machine learning and the different forms of machine learning, it's a whole different ballgame, right? So people are kind of, I think, equating, the accuracy of a calculator to AI, and yeah, it's very different, right?
It is. Yeah, it's very, very different. You're spot on.
Yeah, and it's just, it's the old adage, garbage in, garbage out. And then if it does take the human's bias when they input the data, then yeah, it's going to be a big problem. So yeah, no, I like that.
Exactly.
So, well, I've been asking all my guests on this mini series to give me their definition of the difference between AI and analytics. We've covered a lot of analytics in this show. And now when I start, now that I'm starting noticing AI, there seems to be a lot of overlap. So what's your definition, Curtis, between the two?
I would say that AI and, artificial intelligence and machine learning, first of all, are two terms that there's a debate on this, on whether or not those should be defined differently. So just for the purposes of this discussion, assuming those two things are the same, thinking more about the machine learning definition of AI, I would say it's basically another tool to do analytics. And so analytics is all about finding insight from data and being able to use that insight to do something useful. And machine learning is just another way to get insight out of data, whether it's making predictions or finding groups within a data or, classifying what's in an image or something like that. It's pulling out the insights from data. And again, when we're thinking of, images or sound, those are data sources that maybe aren't as traditional as sort of the tabular format that we're used to of numbers and words. But for a machine learning algorithm, pictures and video and sound are data sources that they can pull insights out of.
So the first thing you're saying is that machine learning, using that in the broader term, but machine learning is a subset of analytics, and you say it's just another tool that we can do analytics. And I think maybe that's where I get hung up on it, because I think of analytics, I guess, in two different ways. I think of it, like you're saying, as a technique, but I also, I equate it with statistics. And I think that's where I get hung up, because I'm thinking analytics equals statistics, and I'm then trying to compare statistics with machine learning. And then it turns out, they're very similar. So I think that's maybe where I get hung up. Can you shed any more light on that? Does that make sense?
Yeah, maybe. It's also been said that machine learning is just probably the most robust way we've ever used statistics. So
interesting.
So it's just using statistics in a very robust way to find patterns and things in data that in an approach that we haven't yet taken to the extent that it's taken nowadays, because we have better algorithms and more processing power and all those kinds of things.
Yeah, and I think the algorithms is a good differentiator too, as I'm kind of trying to tease my way through all these definitions. And I think, one of the biggest issues for business people are to have foundational definitions that they can fall back onto, so they can have a common discussion, based on the same types of assumptions. And the concept of artificial intelligence, again, the more that I dig into it, I see that I like that. I like that. It's the most robust ways to use statistics, but it's like algorithm and use. It's also a big part of it is code. It's like how you apply. It's like a tool is how you apply to statistics. So it's algorithms where you go in and, whether we're talking deep learning or whether we're talking decision trees or whether we're talking, different branches, it's not only the analytical or the statistical technique that's being done. They then take the results. It then takes the results from the statistics and then applies it in some logical way. Right? You know what I'm saying? And so that's at least forming in my mind that it goes beyond just the mathematics, and it combines the mathematics with the programming to be able to, well, I guess maybe get the most out of statistics, like you were saying, this most robust way.
Right.
Does that make sense?
Yeah. And I would say to that very rarely when you're looking at products that AI is in or machine learning is in, very rarely do you see something where it's purely machine learning in a product, right? So oftentimes you'll have So there's two different approaches, right, to programming. One is the rules-based approach, which is historically how programming is done, where you tell the computer exactly what you want done,
right,
and then it does it. And the machine learning approach is you give the computer a goal and you give it some data, and then you tell it to process the data with an algorithm to achieve the goal in the most optimized way that it can.
Right.
And so take, for example, if you're trying to build a product, oftentimes you'll have software rules like normal that will do certain things. And then where it makes sense, you'll flip into, and in the same code, you could write a machine learning algorithm that then processes the data in this other way and maybe comes back with certain predictions. And then you could either feed those predictions into another machine learning algorithm that could do something, or you could feed it into another system, another part of the software system that then goes back to the rules-based approach and does certain things with those predictions. So really these, he's talking about self-driving cars or all these kinds of things. It's really a combination of machine learning processes that are doing the parts that they're good at, and then this rules-based approach that does the part that's good at. You put that all together, and you have a product, right, that does things with the predictions of machine learning.
Now, is it only predictions? Because it's not just predictions, right, that machine learning can do, or would you say it is at the end of the day it boils down to basically just predictions, or is there more?
I would say predictions in the sense that machine learning almost never is 100% sure about what it's doing, right? So,
okay.
So right, there's always like a level of certainty that it'll, so like you give it a picture and it says this is a cat or this is a dog. That's a prediction, right? Now, oftentimes it's accurate enough that you're like, oh yeah, it's just saying that that's a cat. But maybe sometimes it gets that wrong, or sometimes when you're, seeing dogs, pictures of a Chihuahua versus a picture of a blueberry muffin, like is the kind of example. Sometimes it's right, sometimes it's wrong. So at the end of the day, it is making a prediction on what it's classifying. But hopefully, if you see machine learning in production systems, oftentimes the accuracy is very high, depending on the application. Right.
Right. No, I think actually, you really cleared up something in my mind, because I've been equating, when I hear, a term like, machine learning is all about predictions. I guess I was thinking predictive analytics, and then making actual predictions. But you're right. If you look at it in the real sense of the word, it's always making a prediction, because it's never 100% correct. Rarely is it. Well, I don't think it's ever 100% correct. Right. So in that sense, it's making a prediction on whatever it's doing, whether it's a classification or whether it is a prediction. It's a prediction on a prediction. And so, right? I mean, it's always going to be some sort of gray area here.
Right. Exactly. Yeah. Because again, it's not the old rules-based approach where it says I executed those rules with perfection. It's trying to get at whatever goal you're giving it in the most optimal way possible, and that's rarely 100%.
Well, I'd like since you're both a communicator and you get your hands dirty with it, I'd like you to explain to everyone listening how it's actually done, the tools that are used, and maybe just as a framework, and correct me where I'm wrong, but I see kind of two parts, and it could be just from my background in graphics programming, but I see a modeling part where you're developing the model, and then I see an execution part where you're executing the model. So use that framework if it makes sense to you, or if there's a better framework, start from there and then tell us what are the tools, what are the steps, I mean, at a high level, and then we'll kind of drill down on how we actually do this, because everyone listening is again, okay, that's cool, machine learning, but how am I actually going to put this in my product, my system or environment?
Yeah, I mean, there's so many ways you could answer that question, because there are lots and lots of tools. There's lots of vendors that have tools that can implement these things. There's lots of open source code that you can use to implement these things. I could, if we go down the open source road, that's what I'm most familiar with. At least we could hit the principles of how this is done. But there are lots of different ways you could do this. But taking open source code and Python in particular, which has just exploded in popularity, particularly because there's lots of libraries and lots of emphasis on using Python to do machine learning. At its very base, it's a very simple. You could do this with very simple scripting. I don't have a computer science background, but I can code enough, and I've taught myself enough code that I can code up a machine learning process. And so basically what it is you first have to bring in whatever data that you want again, it's data, algorithm, and goal, right? So you bring in whatever data it is you want to feed into the algorithm. And you can very easily do that with Python. There's, lots of functions that you can use to bring that in and manipulate it. Particularly Pandas is really good at doing that. Okay. And then you write a model. And in today's world, that is often, unless you're doing something really hardcore and very specific, oftentimes that can be something as simple as pulling in a library like scikit-learn or XGBoost, which are two really popular Python libraries for machine learning, and typing in the function for building a decision tree, for example. And then within that model, you basically say, here's the data set. You typically will split your data set into a training set and a testing data set. On a high level, there's variants of that, but you feed the training data into the model, and you feed the goal data into the model. So if you're trying to have it predict something, you give it a bunch of data that has known values for the answer, right? Right. And it goes through and tries to decipher patterns that it can see in that data that you sent it to guess at what the answer should be. And then you give it some test data without the answers, and you have it run through that and see how often it gets the answer right versus wrong. And there's various measures that you'll want to do depending on, how, if it's maybe overall accuracy, or if it's being accurate for one specific label over a different label. There's a lot of nuance into how you look at how well your model did depending on your use case. But you'll want to optimize some measure of accuracy or performance. And then,
okay,
go on.
No, I was just going to say, okay, so what I'm hearing you say then is, well, I like the data algorithm goals. So you're bringing in the data, and so in analytical parlance, this would be your extract, transform, and load. And then you're writing a model. And what you're saying is most of the time, and I'll get these library names from Curtis offline, so we'll put them in the show analysis notes. But you're using Python, then you're bringing in then you're using these libraries, and you're putting the data through them. First, the training when you know what the goals are, so you can make the model better. And then I guess with the testing data to test a variation on that subset of the data to see how close it is to the goal. Am I right so far?
Right. Yeah. So and the important concept there is just when you split your training and testing data, you want all that data to be uniform, right? Because what you're really trying to do is have it make predictions where it knows the answer, and then try to make those same predictions when it doesn't know the answer, and then make sure that it does it correctly.
Okay. So the steps that you've taken us through up to this point has been to create the model, right?
Right. Yeah, that's the creation and the training of the model.
Okay. So yeah, and kind of I was terming that as kind of like the modeling part of the model. Okay, so that's probably not a good term, but you're making the model, you're creating the model. Okay.
Yeah.
Now, of course, now this is where things get interesting because yeah, the libraries are there, but the skills are going to be to know what mathematical, whether you use tree, and I can't remember what the second one you used, clustering maybe, I can't remember, but you apply these different you apply these different algorithms to create the model. But of course, the art or the science, or the art and the science, is going to be to know which algorithms to apply to create the model. Is that accurate?
To a point, there is some knowledge there. So let me maybe back up. So there's two parts to this that are pretty important. One is, and I didn't mention this in as much detail as maybe I should have. When you're bringing in your data to feed into the model, there's something known as feature engineering. And that's basically asking yourself, what kind of data should I feed into this model in the first place, right? So, what does the algorithm need to be able to make a good guess at what I'm asking it to predict, right? And there's actually a lot of nuance to that in terms of what kinds of data you want to send in, not sending in too much data. And, depending on what your data source is, if it's images or if it's text, there's just a lot there to figure out what your data set should even look like, what the features of that data set should look like. And oftentimes you'll find that independent of the algorithm that you choose, changing the features can have as much, if not more, sway in what the accuracy of the model is in the end. So that's a really important part about this.
So, but let me understand, what is features simply the data that you're feeding into the model? Is that what features means, or does it mean something different?
Right. Yeah, that's exactly right. So think about it in terms of like a data table, and in one column you have the answers, and then maybe the next three column you have different characteristics of whatever it is, maybe the color of what it is you're looking at, the size, whatever it is. Those are the features. That's the information that the algorithm will use to make the prediction. Right.
Okay. So from a business perspective, one of the things that I preach on this show is the value creation step is you come up, you first identify what the value you're trying to produce with your IoT product system environment. And then so that's qualitating the value, and then you quantify the value with the model. And what you're saying is in this quantification part, yeah, this is, and you could argue that a big part of this is going to be, at least from a business perspective, as opposed to, say, a researcher and art perspective using AI, but this will be the business experts that'll be in their feature engineering, because they're the ones that are understanding the problem that they're trying to solve. So I don't know if this is where the subject matter expert gets involved, or it's going to be in the interpretation, or maybe on some both, but at least from a value perspective, when we're creating the model, we're doing the feature engineering to understand what's the inputs, what's the data inputs for the model. Am I accurate so far?
Yeah, you're right. And there's lots of nuance to this, and there's some nuance here as well. There's certain problems, for example, where it's really important to have a subject matter expert to help us understand, what are the features that we need to put in this model. And especially in an IoT use case, you have to make determinations on when I'm putting these sensors out in the field, like what data am I going to collect in the first place? And what do we think is going to be the most useful for this model, right? So that's, if you put the wrong sensors in the wrong places, that could be a really costly change. So there's a lot of upfront thinking you should probably do into what kind of data we need to feed into this model. But there is also something in certain use cases and scenarios where there are actually algorithms that will help you feature engineer what needs to go into a model, right? So, really? So sometimes you could give, a model, thousands and thousands of features, like in language, there's lots of ways to do that. It's a high dimensional problem. And the algorithm itself can help you determine which features are important. So it just really depends on your use case.
Well, that's interesting, because you're almost implying as if you know what the model's going to be beforehand. Are you implying that? Because my assumption would be you're doing the feature engineering to solve the real world problem and our focus more on the business case. So for creating value for our product system environment. And then after you've done the feature engineering, at least the way I think about it, you then choose what's the best model to be able to represent the features or the variables that we're bringing in to output the value that information that we need. So the value that we're trying to create. Am I thinking about the same way you are, or is there a nuance here again that you want to shed light on?
Yeah, I think that's right. But there's also iterations in that scenario, right? So you may come with a set of data and you're ready to do your modeling. And, there's certain models that would be better at certain use cases than other models. And so you'll kind of think through that and choose your model. But it may be that you're wrong, and maybe another model is actually better suited for it. And maybe another model, again, with the speed with which things are produced in this field, there may be something that just came out. For example, XGBoost is a sort of a new way to do decision trees. Not a new way, but it's a newer way to do decision trees. Decision trees are, and it's kind of taken off in the past little bit because it's so good at a wide variety of use cases. And so, you don't always know the model beforehand when you have your data, and so you can sort of go through several models and see what happens. But you usually know at least an idea of the kinds of models that you're going to want to use for a certain use case.
Right. So, for example, whether you're trying to classify things, whether you're trying to cluster things, whether you're trying to, I guess, use decision trees, so that is to quickly decide on things, maybe that's the wrong terminology, or whether you're trying to learn about things. So is that level that you're talking about, or is it something deeper?
Yep, it is at that level. Again, to your point, your question of, do you want to be able to introspect the model and know like how it made its decision? Like decision trees are really good at that.
Right.
Deep neural nets are really bad at that, right? Yeah. And so if that's important to you, you may end up going with a decision tree. But there's also the question of, there's a lot of just like the problem space that you're trying to solve. Like if you're doing image recognition, there's a set of algorithms that are really, really good at that. Or if you're doing natural language processing, there's a certain set of algorithms that are really good at that. And so that's kind of also what you'll think about.
Okay, and then going beyond that, then you're tweaking once you've chosen the algorithm or the model that you're going to use. Because you're right, yeah, for image recognition or natural language processing, there's going to be a class of these models or algorithms. And then you further tune them, I guess, with the hyperparameters. Is that
that's right?
To go a little bit closer. Can you maybe walk us through that a little bit?
Yeah, that's right. And that's at a high level, that's basically, taking a certain algorithm and tweaking some of the parameters within that algorithm to tell it, how it's going to do its learning. And there are also there's ways to iterate over that as well in a programmatic way to kind of get to what the best hyperparameters are. So that doesn't have to be a completely manual thing, but depending on the problem space and the algorithm you're using, there's typically some rules of thumb that can help you at least start at a good place with your hyperparameters to get to where you need to be.
Now, you mentioned learning. Is it only for learning type algorithms, or would it also be for classification or clustering type algorithms as well?
What do you mean learning algorithms?
Well, you were saying you tune the hyperparameters to teach it on how it's going to do its learning. So are you talking about that in general or just for learning type algorithms? Okay.
Yeah, I'd say in general. In general, they're all learning algorithms. Yeah. So
now there are some in IoT, some IoT platforms, and this is really the plumbing, but some IoT platforms have analytics packages that come with them. And some of them are point and click, like you can do rules engines as it's classified. I'm not sure if they classify it that way in AI or ML, but they have rules engines, which are very simple logical rules that you can take data and do certain things with them. But there's others that are more complicated. For example, a company, what was the company's name? So PTC bought a company called Cold Light, I think it was. And it's not important the name of the company, but it was more of a point and click as opposed to a scripting approach to doing this creation of the models. Have you come across with any point and click type tools that you could actually do anything meaningful with, or is it really the domain of scripting, whether it's Python, R, or even MATLABs, that you really need to get into to create these models?
No, I think there's definitely value there. And again, it depends on sort of the level of sophistication you want with your model. So if you're doing, something like trying to create a self-driving car, then that's going to be code, right? Because you're like in probably TensorFlow or some library where you have a lot of control over exactly what the algorithm's doing, and you are researching and sort of on the cutting edge of creating some sort of algorithm that can really do a good job with your specific use case. But there's also a lot of use cases where, image recognition is a great example for certain things, like recognizing faces, for example. Those kinds of algorithms have been around for a long time now, for enough time that they are mature, so to speak. And so if you're doing something like that, trying to do an image classification in a domain that's already well studied, that may be a good way to use more of a point and click kind of an interface, because you just need to drag in kind of an algorithm that's already well understood and connect it with your data and those kinds of things. And that's more of a, data engineering kind of a problem than trying to come up with a new sophisticated model kind of a problem.
Okay. So you're saying, yeah, I guess that makes sense. If it's well established, then a point and click might make sense. And you're not talking about just, the what is it called? The augmented learning or the human helped learning. What's the terminology? I'm just blanking on it right now. But machine learning is either autonomous learning, where the machine just learns it, or it's being guided by the operator. You're not talking about that. You're talking about actually applying the entire algorithm to well-defined problems such as image recognition or something along those lines, where it's been thought through the hyperparameters. Maybe they've got like 5, 6, 10, 20 different ways that you can presets for the hyperparameters, but you can kind of just point and click your way through it. Is that kind of what you're saying?
Yeah. And in fact, there's also other thing. Google just came out with, their auto machine learning product, where essentially it's an API that you hit, and that's particularly good at machine learning. So they'll take, not machine learning, image recognition, which is machine learning, but particularly at image recognition, where they have, they've built so many models that can recognize so many different kinds of things in images that you can oftentimes, in this case, just use their API and use their models they've already built, and either use those models directly or slightly tweak those models to get at what you're trying to classify.
Okay. Yeah, what I was thinking about before then was supervised learning versus unsupervised learning. And obviously you're going to need some mechanism if you are doing supervised learning to get to those, models that can recognize a chihuahua versus a blueberry muffin. You're going to need some, right? I love those images. I think everyone loves those images. I showed them to my daughter, and then she Googled up and she found she Googled animal classified as food or something like that. And like a whole bunch of these came up, like donuts and chicken, fried chicken. And in any case, for the supervised learning, that's not what you're talking about, right? That's a different point and I guess that's a point and click kind of endeavor where you're in the learning phase or the training phase, where you're helping the algorithm out, right? And what you're talking about is just more in general it's a well-known problem where the whole thing is kind of point and click or can be point and click.
Right. Yeah, I was more talking about the latter. To your point, though, the distinction is important, and we haven't talked about this yet, but the difference between a supervised model versus a unsupervised model, the difference there is just a supervised model is where you can feed data to the algorithm where you know the answers, so it can learn exactly how to do that. Whereas the unsupervised is more, you feed it a bunch of data, and like a clustering algorithm, for example, says, here's a bunch of data, find some interesting patterns in this data, right?
Right. No, that's important. And so if you have, and sometimes, that's like tag data versus untagged data. And sometimes, people are talking about in IoT, they call, and maybe they use the same terminology in AI, but in IoT, they call it data exhaust. And then there's this romantic notion that you've got this, 2 terabytes worth of data, and you can just sort of find something useful. And at first, I kind of totally dismissed this because I said, this is like finding a needle in a haystack. But really, this is a problem of what you were just talking about, of unsupervised learning, where you may not have thought about these classifications, but if you run these 2 terabytes through different models and algorithms, they may find some insights that were completely unexpected. Have you come across anything like that yourself?
Yeah, I was about to actually comment that in everything that I've seen, or most of everything that I've seen, and other people as they are talking about the value of machine learning, most of the cases that you see where the value is under the supervised model. That's a lot of the applications that we're seeing come out. And there is some value in certain applications to the clustering as well, but a lot of the value is coming from the supervised models.
Okay. And that's kind of my intuition. So is this a 90-10 or an 80-20?
Yeah, I don't know. It's 80-20 rule, maybe roughly.
80-20 rule? Yeah. Okay. No, that I guess that's good, because that's kind of, that's sort of my feeling. But then as I dug into this a little bit more, I did learn, a little more about the unsupervised learning, and I could see in certain circumstances, and I guess maybe 20% of circumstances, where there could be some value. Okay, Curtis. So now I want to switch gears. So we've created our model. Now in IoT, we want to execute this model. We want to run it within our product, whether that's a car, whether that's a clothes dryer, whether that's a surgical tool. How do we then take this model that's going to be pretty complex and then execute it? So a very simple example, if we had a spring and it was F equals KX, just a straight linear line, we kind of go along the x-axis and we want to know what's if we apply this force, what's going to be the compression. So we just sort of go up the y-axis and then we, go across over and we see where it intersects the model. And then we get some sort of, we can execute the model. Now, obviously in machine learning, the number of variables are quite a bit higher than that, but I think the concept's the same. So how do you now execute these models once you've created them, whether it's been point and click in some circumstances or more likely scripting? How's that done?
So I could answer this question a little bit more in generalities, because we don't have anything that I've worked with to this point. We've haven't had to put models on devices, so to speak. All of our processing is done in a central cloud
kind of like
computing
a post-processing.
Post-processing, right? And so so that is one strategy, where you send your data from the device into the cloud. It does the processing, sends the predictions back. Doing the predictions on the actual devices themselves, I believe, is what's known as edge computing. And some different strategies for that, maybe just in general, are, if you're doing it in a cloud environment, obviously you can afford to have your model be really, really complex. But if you need it on an edge device, perhaps what you want to try and do is reduce, for example, the number of features that your model requires to make a prediction. And maybe that requires a little bit of a reduction in accuracy of your model, right? So maybe I can reduce the computing power by 100-fold, and I'll take a 3% hit on accuracy. But that's okay, because now I can do it on this small device, right?
Right.
So it's just a trade-off there in terms of, how much processing power does your device have, and how can we simplify the model with the least amount of reduction of accuracy to be able to fulfill, the use case that needs to fulfill.
That makes sense. Now, what I'm wondering then, are there libraries that also are provided? Because there's libraries that they're using with scripting, and I guess there's algorithms using with the point and click. But are there libraries then that do the execution? I guess that's just another type of call within the script. So you'd have to then, instead of have it within the script, have it being controlled by the application. And your point is well taken. The model's going to have to be simplified. In fact, you might want to do a model of a model, to simplify it to the point where you can execute it. But is this something that is hand coded, or is this something that's provided with these different libraries as well?
Yeah, I mean, it could be all of the above. One interesting thing that I'll note there, since you're talking about libraries, I have not used this myself, but I know there is a way to implement TensorFlow through JavaScript now. So that could be a way to again put these models on anything that can execute something on the internet.
Right. Okay. No, that makes sense. Well, this has been good because, up to this point, it's been more theoretical, I guess, so to speak, on the podcast series that we've been doing on AI, and we've learned it's really machine learning, really, and that we're talking about here. So it's been nice to kind of, expose what's actually being done. So thanks. I think everyone appreciates your point of view on this.
Yeah, no, it's been fun. It's been a great conversation.
So, Curtis, where can people find out more about you, your podcast, your company? Where should they go?
Sure thing. If you want to, give a listen to the podcast, it's DataCrunch. You can just type that into your browser and you'll find us. DataCrunch, iTunes, any of your podcatchers, you can find us. Okay. And also we have a website called vaultanalytics.com where we write about all these applications that we find on a daily basis and have a newsletter that goes out as well. So we love your feedback there. Our email address is curtis@vaultanalytics.com. Feel free to reach out to me. And I'd love any feedback that you guys have.
Excellent. Well, thanks a lot, and we'll be in touch soon.
All right. Thank you so much.
Okay. That was a good talk with Curtis Seare of Vault Analytics. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book, IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Balancing the Tension Between Informed Analytics and Black Box AI with Drew Conway. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a scripted one.
You have been listening to the IoT Inc. Business Show.